Okay, moving on, we are going to turn our attention to the output diode notes. Now, if you'll notice in that application schematic, there are actually two output diodes. There's one that goes to the output of our actual output voltage that we specified, the 5-volt output, but then there's also another one required for the output on the auxiliary that's actually going to power our chip, right? And they work the exact same way. Like the auxiliary output works the exact same way as the secondary output, in the sense that we need something like we need diode to rectify it. And the conditions are a little bit different, but it's easier. Like whenever you're shopping for a diode, what I usually do is you just find like the worst case scenario, and then you just find a diode that fits that one, and then you just copy it over to the auxiliary winding. So for example, in these calculations, the first parameter we take a look at is the voltage peak reverse max rating. So this should look very familiar to our rectifier diode part whenever we were shopping for a diode that can handle the rectification part from the AC to DC conversion. Again, we're going to calculate the voltage peak reverse max. And the equation they give us for this one is we have V out plus VDC max times V out plus VF over VRO. And then VRO, this is the reflected output term. And I think I got this equation from, because this one isn't mentioned in this data sheet. I found it online and I searched around other places. So this is the one I'm using that they specified. So it's a little bit, maybe you're probably like a little bit curious, like, well, this doesn't really follow the exact like the same steps that we did for our rectifier diode output, because we didn't really have an equation like this. Like why are these terms in this equation for us? And I would say like the reason for that is these terms are in here to try to give us, again, like a case of maybe like the worst case scenario of like an improperly functioning output or improperly functioning system. And I guess the conclusion here is that having a diode fail and allowing basically AC, alternating current, to flow to the output is a worse case scenario than having to buy a more expensive diode, basically, or having to source a diode that can handle this. Because quite honestly, it's pretty easy to find a diode that has a value that is, something like this. I mean, granted, honestly, when you do the equation, it only comes out to 8.69 volts, but it's still substantially higher than, it's like almost 100% higher. No, it's like 50% higher than the output. So, I mean, yeah, that's the equation that I end up using for this. So you get a V peak reverse max of about 8.69 volts. And so, I mean, like I said, I think the diode I sourced has a VPR max way higher than this. And I think the reason for that is also the next important component parameter that we're going to get into, which is the current rating. So this is like the continuous current drain rating here. It's just basically the amount of current it can handle. And in our application, and this is actually something you'll notice when you're speccing components, is that whenever you're trying to find a diode that has a VPR max that's greater than 8.69 volts, like that could be a walk in the park. Like you could find those, just anywhere without even trying. But then the thing that you have a much harder time finding is, like, say your VPR max of a diode you pick is like 15 volts. You're like, oh, that's way more than I need. Finding something that can handle, has a VPR max of 15 volts but can handle 1 amp of current, that's where it gets harder, right? So when you're speccing your parts, like I would say, it's you're get a feel for what extreme values look like. So I will say 1 amp is approaching an extreme value. It's definitely above average for the type of applications that we'll be featuring, type of designs we'll be featuring on this project. Like usually you're not going to see, like we'll do plenty of applications that have like 50 milliamps of current or 200 milliamps of current. Like that's a more typical case scenario for the projects we'll be doing here. So 1 amp it's getting up there. It's pretty high. So with that being said, we know that our specification is for a 5-volt 1 amp converter, so we are going to be looking for something that can handle greater than 1 amp of current. And again, I say leave a little bit of headroom in case something happens and it shorts for a little bit. We don't want our diode failing as well, okay? So yeah, so look for something with a forward current rating of greater than 1 amp on that. And that pretty much will do it for the output diode portion of this video, of this series.